Okay, so hopefully you actually came back for the second video here and are continuing with your notes. So now we're going to talk about tangents. So you can recall your graph of tangent, we limited the domain to be from negative pi halves to pi halves. The range of tangent is actually going to stay from negative infinity to infinity. So thinking about that. Well, why do we have cross brackets there? Because at negative pi halves and at pi halves, we have vertical asymptotes. And you're still going to have negative pi fourths. You're going to be at negative 1, 0, 0 at pi fourths. 1. So you'll just have your basic tangent. So now when we look at tangent inverse of x, well, your domain is actually going to be that negative infinity to infinity. And your range is going to be the negative pi to pi half. So what's happening here is instead of vertical asymptotes, think about what happens when you invert it. You are going to have horizontal. So you actually have a horizontal at y equals pi halves and at y equals negative pi halves. And then instead of the order pair like pi fourths negative 1, you have the order pair negative 1, negative pi fourths, 0, 0, and so forth. So your graph here should look something like this. Okay, so now we're going to move on to actually evaluating some of these trig functions. And the notation is important. So these are all equivalent statements. So it doesn't matter if it's sine inverse of x or arc sine of x, it means the exact same thing. So if you see arc cosine, arc tangent, you're really just asking for the inverse function. So that's just a little notation there. All right, so evaluate the following problems without a calculator. These are all unit circle values. Whenever you are taking an inverse trig function, what it's actually asking you to do is tell me the angle. So for instance, if you have sine inverse of radical 2 over 2, what this is saying is, at what angle is my sine value radical 2 over 2? So every answer here should be an angle value, like a pi thirds, a pi fourths, a pi sixths, something like that, where your answer is going to be an angle measurement on the unit circle. Now, we need to, however, give our answers so that it meets the range requirements of our inverse trig function. So you may recall for 1 and 2, we limited the domain of sine, thus the range of sine inverse, to be negative pi halves, pi halves. So our answers here have to be in that range of values. All right, so what it's asking for number 1 is, where on my unit circle is my sine value radical 2 over 2? A positive radical 2 over 2, well, that's going to be in, you are at pi 4. All right, for number 2, it's saying, where is my sine value? Negative radical. Well, it's negative 2 in quadrant 4 at my pi 4. Now, we would traditionally write that as 7 pi 4, but 7 pi 4 is not in that range of values from negative pi to pi. So instead of writing that as 7 pi 4s, we have to write it as negative pi 4s. So you have to write it as the coterminal angle to that using negatives, because it has to be in this range of negative pi halves to pi halves. Right? So looking at cosine, well, we've limited the cosine inverse to give us values between 0 and pi. Right? So every answer has to be between 0 and pi. So cosine inverse radical 3 is asking, where on my unit circle is my x value positive radical 2? Well, that's going to go right to 1/2, which is our pi 6 value. For number 4, where is arc cosine negative 1/2? Well, where is it negative 1/2? Well, that occurs where? So it has to be negative, so we're in quadrant 2. It's going to be that negative 1/2 3 over 2, which actually is 2 pi. For number 5, arctan of 1. Where is my tangent value of 1? Well, remember, tangent, it's your sine of theta over cosine. It's your y over your x. So where is my ordered pair where my y value is 1 and my x value, or rather, they're the same, right? That has to be a pi force. It needs to be a positive. So it's going to be at pi force. Where is my arc sine value? 1. So my arc sine is 1. So what this is saying is, where is my sine value? Positive. Where's my sine value? 1. Right there. All right, so what I would like you to do now, if at all possible, is pause the video so that you can keep going and try the next couple on your own and see if you can answer 7 to 12 on your own. I'm going to keep going. Arc cosine is just saying, where's my cosine value? On my unit circle, where's cosine value? Equal to 1? That's a, it's 0. Sine inverse of negative 2 is really saying, where is my sine value? Negative 2. Well, here's the deal. When we limit the domain of sine to give us answers from negative pi halves to pi halves, the domain of sine inverse is negative 1 to 1. So when I go to plug in this negative 2, that's not in the domain of sine inverse. So sine inverse of negative 2, I cannot do. It is not in the domain. So your answer actually here. For number 9, where is sine inverse? Well, where is sine negative 1/2? So sine inverse is negative 1/2. So where in my unit circle is my y negative? Well, that's going to be here at the on here. Didn't choose this one. Or sorry, radical 3 over 2. So that's really 11 pi over 6. But my problem is I need to write it so that it is between negative pi halves to pi. So instead of 11 over 6, I write that as negative pi over 6. All right, so keep going here. Cosine inverse of negative radical 2. Where in my unit circle is my x value, my cosine value, a negative radical 3 over 2? That's going to be here at 5 pi over 6. For 11 and 12, you have to think a little bit here. Tangent, sine over cosine. So I need my y value over my x value to simplify to radical. So I need it to be a radical 3 over 2 and a 1/2. So where is my x value? 1/2. And my y value, radical 3 over 2. Where's my x value? 1/2. Y value, radical 2. Well, that is pi thirds. For tangent inverse of negative radical 3 over 2, or sorry, negative radical 3, I need that to simplify down since I'm running out of time. Think about that for a second. That is actually going to occur once again at 11 pi over 6, which is negative pi over 6. And so that wraps up this second video here. You really need to know your unit circle. Good news is, for those of you that don't know your unit circle, next video we are going to move on to